All right, so we're graphing. This is homework on graphing, and I will have posted this key. Now there are some of them, there's two of them in here if I remember right, that aren't real nice, but let's go with what we have. So the first thing I want to point out is that we're starting with, it's funny that this is the very last thing that we look at when we look at A, B, C, D, but this is our midline. And it's important to know where to start with your midline. So you're starting at -1. So I'm going to make solid line for my midline. Okay, and then this also tells me that starting with a 4, that's my amplitude. So I go up 4, 1, 2, 3, 4. This is 4 units up. So I'm going to go ahead and draw my amplitude line. And 4 units down, 1, 2, 3, 4 units down. That's my bottom amplitude line. Okay, that's amplitude. And then this is 1/4. So that's telling me like how it starts off. Oh, by the way, I'm starting with sine. So if I'm going to graph this, I would start on the midline at 0. But what I don't know is the increment, and I have to figure out the increment. So notice right here, this b is equal to 1/4. So if b is 1/4, the period is going to be 2 pi over 1/4. And if I put that in a calculator, I'm just going to show you, I'm going to inverse and multiply. It'd be 2 pi times 4 over 1, because a fraction like this, that's 2 pi over 1/4, means it's 2 pi times 4 over 1, which is 8 pi. So I'm going to go from 0 to 8 pi, and my increment is period divided by 4, so 8 pi, over 4, so it's 2 pi. So I'm going to climb by 2 pi every time. 2 pi, 4 pi, 6 pi, $1. Okay. Yeah, an old cheer from my very young age. All right, so I'm going to go out 2 pi, and at 2 pi, I'm going to hit, it's positive, so I'm going to go up and I'm going to hit the top amplitude. 2 pi again, and I'm going to hit the midline. 2 pi again, so it's every 2 pi, that's an increment. Now I'm going to bottom out and hit the bottom amplitude line. 2 pi again, I'm back to the midline. All right, so that's where we do our graph. Wow, I kind of missed. Okay, so these should always have arrows because they continue. If you want to keep going, you go 2 more pi and you're hitting the top. Whoops. Hitting the top, it should be here. You go 2 pi more and you're back on the midline, or you could have gone back 2 pi and keep going midline amplitude, midline amplitude. Now I want you to notice how I graphed this whole thing, and I didn't, not one time did I use, technically this should have been a little bit more like this, because it should hit the top and keep going. I try really hard not to make these look like, I don't want to erase it because my first part of the graph looked good. I guess I could take white and do that. But anyway, you don't have to fill this out. You can. If you want to go, oh, this starts with 0, 1, 0, -1, 0, and it was multiplied by 4 and subtract 1. So 4 times 0 is 0, minus 1 is -1. 4 times 1 is 4, minus 1 is 3. And then these are both -1. -1 times 4 is -4, minus 1 is -5. You'll see that you get all of these major points that was pointed out, okay? If you want to do this, you can, but it's not necessary. I got my points with or without that, and this one shouldn't have been in there. That one was a mistake. I can't erase that. All right, so just saying, let's go on to the next one. Here, the amplitude is 1, the midline is 1. Okay, here's my midline. There's the midline. And then, and this is at y equals 1. And the next thing I'm going to do is say, oh, the amplitude is 1. So I'm going to go up 1 and down 1 from the midline, not from 0. And then since the b is 1, I know that pi over 2 is my step. So I'm going to go 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's where all the magic happens. I'm going to go in here in green, and I'm going to graph at 0, pi over 2. I go up, come back, go down, go back up. The biggest thing is knowing what the increment is. If you wanted to keep going up to and back down to here, and this one would end up down here. Because a lot of times we ask for 2 periods, so 1 complete cycle is a period. Oh, I went way down too far over there. Dang it, I was doing so good. Unfortunately, I have to erase this, and it's going to get rid of all of it. Okay. That's more than enough, but it does continue to go. A sine curve goes forever. The domain for these are all real numbers. It just keeps going and going and going. Range is definitely in between the 2 amplitude lines, okay? All right, so again, notice I did every bit of this without using any of this. Now, if I want to use it, my magic numbers are the 0, 1, 0, -1, 0. Where do these come from? It comes from the unit circle where all of these hit, where the sine value is. And remember, it's cosine, sine. So it's all of those sine values. These are the magic numbers. But I don't need the magic numbers. I need to know where my amplitude is and what my increment is, and then I have it. All right, just saying. This is one of them that I didn't do because it didn't come out real pretty. I can tell you a couple of things about it. I know that I have a midline of -1 because it tells me that. And this is over 3, so this means the period is equal to 2 pi over 1/3, which is 6 pi. Oh, this one may have been okay. Oh, it's number 4. That's awful. This one's okay. I'm so sorry. We are going to do this one. And then for the increment, I'm going to divide by 4. 6 pi over 4, which is 3 pi over 2, which is not nice. Okay? I'm just here to tell you that's 1.5 pi. I can do it because it's not horrible. So the first one is 0. The next one is 3 pi over 2. Or think of this as 1.5 pi. Well, what's another 1.5 and 1.5? It's 3 pi. Okay, and another 1.5 is 4.5 pi, which is 9 pi over 2. And then another 1.5 pi is going to put me, it was 4.5, so it's 6 pi. Okay, so with all of that said, I figured that out. And now my amplitude is 1. So that means I have these amplitude lines at the 0 and the -2. So as scary as this seemed, it's really not all that bad. It starts at 0. It starts on the amplitude, not at 0. It starts on the amplitude, on the midline. And we know we have to go out 3 pi over 2. So 1.5 pi. Here's 1.5 pi. There's another 1.5. Here's another 1.5. Here's another 1.5. Okay, so as crazy as it seemed, it's not that bad. So I've marked all of them, and this is going to be a mark This is going to be my next one, and then it's going to bottom out for this one, and then it's going to go back to here. If I wanted to go up 1.5 more, it would put me here. 1.5 more, it would put me at 9. It would put me there. So if I wanted to keep it going, I can. And it is so hard to draw on this tablet. I really can't talk when I'm doing it. I always want to have arrows on this to include the fact that it can continue to go on and on and on. Notice I didn't even fill these out. I'm not even worried about those, okay? Then let's go look at this one. This is the one that came out kind of ugly. So I will tell you what I do know. I told my kids to leave this off originally and not to bother with it. So there's the 2. This has an amplitude of 2, so I'm going to draw in the amplitude of 2. 1, 2. I want to say this one just had some weird numbers. It's off by 5 pi over 6. This is almost a whole unit of pi. So C is negative 5 pi over 6. This is why I had them not to do it, because I have to go out 1, 2, 3, 4 units to pi. This is not quite pi, but it's 1/6 away from being pi. So I would have to go back 4 units. 1, 2, 3, 4 for pi. It's going to be somewhere in here. Okay? And in fact, it's going to be somewhere up here to start on this line. And then it's just starting in a really weird place. It's just, with these labels, it's not conducive. I don't like it. Just saying, I don't like it. It's going to start at negative 5 pi over 6. It's still going to have increments of pi over 2 because my b is 1. So if the b is 1, it's going to finish in 2 pi. So this will be, yeah, it's just crazy. It's going to be 7 pi, I think it's 7 pi over 6 is where it's going to finish up. 7 pi over 6. 7 pi over 6 is going to be right before 2 pi. It's going to finish about here. And it's going to start about here. And it's going to hit in the middle somewhere around here. Somewhere in the ballpark of just under pi. Let me think. It would be just shy of 2 pi, but down below. Oh my gosh. Oh no, it's going to stop here. My bad. It's going to stop here. That's going to be where it ends up. And so somewhere in this ballpark is going to be the middle of it. So it's going to go up, down, and back up to here. Somewhere like that. It will hit that again, but not, actually it won't hit right there. It's going to be going up and down like that. It's just ugly. Yeah, number 4 is bad. Don't do it. And then I think it's number 7 or 8. Yeah, number 7. It's number 7 that ends up so bad on this one. And then now we haven't done cosine, but just because we have one here, I'll show you how to do cosine. So again, I'm still going to start with the midline. I want you to see how similar these are. Midline, amplitude of 3, 1, 2, 3. Down 3, 1, 2, 3. Now these amplitude lines are actually really important. It keeps us from not having to use this information. So I've taken care of the 3. Now to take on this 2 business in the middle right here. So our B is 2. So that means I have period is equal to 2 pi over B, which means I'm going to finish this thing in pi units. So period equals pi, increment equals pi over 4, because I take whatever the period is divided by 4. That doesn't change for cosine to sine. So now that I've got that, I'm going to go, okay, here's all my important parts. A quarter pi, half pi, 3/4 pi, and pi. Now the difference between cosine and sine is that cosine starts on the amplitude. And this is a positive cosine, so it's going to start on the top amplitude. All right? A positive sine starts on the midline, but the first thing it hits is the positive amplitude, not the negative one, the one down below the line. Okay, so this one is going to go from the amplitude to the midline, to the bottom amplitude, back to the midline, to the top amplitude. Now, if I wanted to keep going, because you should, as far as the graph takes you, every one of these that we hit, every pi over 4 is going to be another line. So these are not chevrons. They are a sine curve that just happens to start at the top. And I'm better at rounding off the ones on the top than the ones on the bottom. Look at that. All right, and these continue on forever. That's what they look like. That's a cosine curve. Sorry, it's a little on the lumpy side. I'm doing the best I can do. But my increments are pi over 4. It started at 0, and you can fill these in, pi over 4 and so on. And this one's pi over 2, 3 pi over 4, and pi. So notice the standard graph of cosine looks like this. And you're welcome to go back and see the examples that I have. All right. Just again, how simple this one is. You get out -2. Here's the midline. And this B is 1. And the A is 4. 1, 2, 3, 4, dotted line. 1, 2, 3, 4, dotted line. I actually love doing these. They're really easy. It's positive, so it starts at the top. My increment, well, the period is equal to 2 pi over b, which is 1. So it's 2 pi. The increment is to take 2 pi, put it over 4, which makes it pi over 2. So every pi over 2 is where something's going to happen. And each one of these are marked at pi over 2s, which is nice. It starts at the top, goes to the midline, then down to the bottom. I'm laughing at myself because I kind of missed the midline and went to the x-axis, and back to the top. So standard cosine curve. And I'm trying my best not to make these lumpy. Again, it's very hard for me to do it on this tablet. But you could continue it, which I would recommend that you do, because usually on a test you have to do at least 2 periods. Okay? And that's it, continued. And you can see I didn't need this at all. So if you don't use that, I'm not going to lose any sleep over it. I hope this helps you. This is a short rendition of what we were working on. So I hope this helps.